All right, so we need to figure out what is the thickness of the wire that is here. And so what I'm going to do is basically put this around the wire. I've loosened up the wire so that I can actually get it into the micrometer. I haven't tightened it all the way, so just sort of listen for the clicks. There we go. So we now have it clicked. Now it's a matter of reading the value right there. And obviously it's not particularly thick. The next thing you do is I'm going to show you a series of pictures for 5 different thicknesses. And don't forget to subtract the baseline, which is the very first photograph. This is a resistance wire board. It's basically a meter stick that has been glued to an insulating base. And what we're going to do is we're going to hook up the multimeter, or the ohm meter part of the multimeter, to each end of it. And we're going to press down on this, and that's probably a bad spot right there. I'm going to press down on this and then measure, in essence, the resistance of the wire plus the resistance of whatever I've hooked it up to. But since the wire is the skinniest, this should be the bulk of the resistance that's coming from the wire. The material of the wire, I'm pretty sure I know what it is. I don't have the specs for this, but considering similar type things that you can buy now, I have a pretty good idea what it is. We have the multimeter hooked up from using a banana plug here and then the alligator clip, and then hooking it to this spot over here because it's easy to clip it to that. This is a conducting material here so that any current that I want to run through the wire to measure resistance would obviously be able to go through that. I'm going to be able to tighten the wire by pulling on this one over here, so that will keep this flush. I have the other end of the ohm meter hooked in through the red wire and into the clip right there. Let's put this on ohms. And we should have an infinite amount of resistance, or at least close enough. And when I push down on this, we'll make contact between this sliding piece right here and the wire. And so notice that the resistance suddenly is not out of range of this material, and it's 5.2 ohms at the moment. Now it is going to vary a little bit. Now here's some of the issues when doing this. The instructions talk about doing a measurement every 10 centimeters. And so it would be very convenient to do 10, 20, 30, and so on. Except at the odd ones, at the 10, 30, 50, 70, and 90 centimeters, there's a nail there. If I push down on the nail, the wire is not necessarily going to be trapped between the nail and the clip right here. The wire could get pushed off to the side, in which case you get some really strange results. Matter of fact, there was one class, I remember specifically, at least one member of that group, where I went through this spiel and I said, do not do that. Make sure that you are not pressing down on the nail. And then about halfway through the lab, I looked at their results as I was wandering around, and I saw that they were strange results, and lo and behold, they were pushing down on the nail. So you are not going to make that mistake because I'm doing this lab. And let's start doing some measurements here. Now, there's going to be a potential coordination issue. We're going to find out. As I push down on this, I need to be steady when I'm pushing down on it. If the numbers are jumping all over the place, it could be that my hand is shaking slightly, in which case I might take a book and put a book down on it. I don't want to push down on the nail, so I'm going to be a little bit off. And you went down to the nearest, I think the instructions asked for the nearest millimeter. So I push down there, and come in close. So you want the nearest millimeter of the front edge of that clip. And that is jumping all over the place, so I need something steadier. So I'm going to get a book. You want the position of the front edge of that clip. Let's see if I can get it so that we're straight on the flat edge there. There we go. Somewhere around there. And that is the resistance. Now it is fluctuating between those two numbers, between those three numbers. Let's see if we can get it to settle. So whichever number it seems to spend the most time on. All right. You want the nearest millimeter of the front edge. And again, to avoid parallax, obviously that's too far because you can see the front face, and that's too far because you can see the back face. So I want to be straight on the edge there. Too far. Just like this. So you want the nearest millimeter, the front edge of that, and that is the resistance. Again, going through the same drill here. I hope you can see that that's the nail there at the 30 centimeter mark. And that is the resistance there. Also point out, it's fluctuating between the two. You sometimes can estimate the unseen digit, do an estimated digit on this, even though officially you can't, just by how much time it spends on the two values there when it fluctuates between two. And I don't know why I'm focusing on that. That is not meaningful data at the moment. Now let's go down to near the 40 centimeter mark. Put the book on it. And I'm assuming that you're going to pause it if I happen to hit just right, because that's too far. That's too far. Somewhere around there. The front edge. And I'm saying front edge. You can actually pick either front edge or back edge, just so long as you're consistent throughout. And that is the resistance. Let's go on to the next one. Okay, the nail is there, so I need to make sure I'm not on the nail. And you can see a little bit of sunlight coming out underneath it, and that's because there's a wire allowing a little bit of a crack there. Crack in both senses of the word, of the small opening, as well as just the Irish word for a whole lot of fun. Moving on to the next one. So somewhere around there, to the nearest millimeter. And there's the resistance. Now to roughly the 70 centimeter mark. And there is the resistance. And then on to near the 80 centimeter mark. And the resistance. And then the last measurement here, or perhaps the penultimate measurement. I think I might add another one here. That darkened number under in the shadow there is 90. And there is the measurement. And lastly, I'm going to pick the one out here as well near the 100 centimeter mark. And to do that, I'm going to press on this one instead of that one. This one is not touching at the moment, so this would add to no resistance at all. We don't have to worry about where that one is located. I just need to make sure that it is not pressed at all. And we want the front edge there. The front edge would be the one closer to the red clip. There is the resistance. Yeah, there we go. I did pick up the front piece. Turned out I was pressing on it some, so I picked up the front piece there. And that is the end of part A of that lab. So the original version of the lab, we just used 2 of these, but since we don't have groups fighting over them, we can use 4 of them. We could actually probably go more. I think I only brought 4 from school. So just sort of give you a clue about what's going on. We're going to be measuring the resistance between this point and this point over here. These are the 2 leads that are leading into the multimeter right here. Now it's going to be measuring the resistance of, well, not only the wires that I've added, but also the wires that are on the board. So let's take a look at that. So in order to measure the resistance, the multimeter tries to send a current through it. It's going to send a current to here, and at that point, it's going to run through that wire right there. If we look at the underneath of it, so the current's going to be running along here. It's going to go through all that wire. It's going to split, but this path has so much less resistance to it, it's going to bypass that. And that's what this jumper right here is doing, is it bypasses that right there, because this will have so much less resistance than that will. Now, in terms of why am I setting it up this way as opposed to just putting, leads here and here, these first 4 are all copper, and this last one is a nickel-silver combination. And these 2 right here are skinnier than those 2 right there. So these are the number 22 copper, and these are the number 28 copper right here. So we'll do both experiments, one with the 22 and one with the 28. The current's going to run here. It's going to go through that, jump over, most of it will jump over to here. It'll then go through this wire right here. This is 20 meters of number 22 copper wire. Then it's going to get to here. At this point, it's going to jump over to this one. It'll go through that, bypass, go through this wire right here, and then jump over to here, and so on. And so that's the setup. So right now we have, it's going to go through 10 plus 20, which is 30, 60, 90, 120 meters of copper wire, and we get that resistance right there, which is not a heck of a lot of resistance. And then we're slowly going to take off bits and pieces. So if I want to remove 10 meters of copper, I just need to take that, put it into there. It's going to get to here, and it's going to bypass both of those and jump to here. So this is 110 meters. This is 110 meters of copper. Now I want to bypass 20. I want to get down to 100, so I want to put the 10 back, but I want to eliminate the 20. 100 meters of copper. Now when I get down to 90, removing 10 every single time, that is now completely out of the picture. And so now we're down to 90 meters of copper. I want to get down to 80 meters of copper, so I'm going to extend that jumper right there. So I just got rid of that 10. So this is 80 meters of copper. And now to get down to 70, I'm going to put that 10 back and jump over that. So that is 70 meters of copper. To get down to 60. Now, you might be asking, why am I keeping around all of this wire right here? I'm keeping around the wire because that is sort of a control. That's the amount of wire that I'm using. And so I want to at least maintain that. Because, I mean, it does add, even though it doesn't add much resistance, it does add something that's officially not zero. Now, how much it is, potentially you can catch it from the graph and potentially not. It depends. But we're now at 60 meters of copper wire. Now I'm going to get down to 50. So let's take out that 10 right there. So 50 meters of copper. And now I want 40 meters of copper. So let's put the 10 back and bypass the 20. So 40 meters of copper. And now let's get down to 30 meters of copper. So that one's out of the picture, and we are now bypassing, we're eliminating that one from the picture. So we're now down to 30 meters of copper. And it seems to be a little bit unstable here. All right. Now let's get down to 20 meters. So we'll bypass the 10. Test current will run through here. It'll skip over all of that and then go through the 20 meters of copper. Now we want 10 meters of copper, so we're going to bypass that. And so 10 meters of copper, plus all the wires. And to give some sense of the wires themselves, how much do they add to it? That is just the wires themselves. Now we're not going to take that number into account. I'm just showing that there is a non-zero resistance, which is one of the reasons why we'll ultimately find the resistivity using the slope as opposed to any of the exact numbers here. Now we're going to perform the exact same experiment, except we're going to do it for the number 28 copper. So I'm going to pause this and set up for the number 28. Doing one last scan here, make sure that the number 28 copper is being measured, that we bypass anything else. And so we get to the number 28, go through that, jump, go through that, jump over to here. Good. 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 120 meters of copper. $110 meters of copper. $100 meters of copper. $90 meters of copper. $80 meters of copper. Number 28 copper. $70 meters of copper. $60 meters of copper. $50 meters of copper. Just a quick glance there. So you still have the 30 from that, and then it's bypassing that 10 right there. So we basically just picking up the 20 there. So 50 meters of copper. Number 28 copper. Just do the best you can on what the actual measurement is. Again, just making sure my connections are good. Putting the 10 back, taking the 20 out. So we now have 40 meters of copper. $30 meters of copper. 20 meters of copper. Ten meters of copper, number 28 copper. And then finally, 0 meters of copper. This would be just those additional wires that I had strung in there. That's a different value than what we had before, but there are statistical fluctuations. The actual value ideally would come out in the graph, but it depends on how big the error bars are. Feel free to use linS to get an actual value of the error bars that are appropriate. All right, now it's time to record and number crunch.